Greetings to everyone. My name is Mark Payette. I am an orthotist at Tamarack Habilitation Technologies. Thank you all for attending this presentation, Fabricating New Tamarack Components. And thank you also to the Academy Education Committee for all the work putting this conference together. For full disclosure, I am an employee of Tamarack Habilitation Technologies. Tamarack has developed a comprehensive family of orthotic ankle joint and motion control components, as well as materials to strategically reduce friction. This chart shows the many varieties of ankle joint componentry currently available. You are likely familiar with most of these options. This presentation will focus on the fabrication process for the two newest component products, the Tamarack Flexure Joint Caps and the Tamarack Plantar Flexion Limiter Kit. We will also introduce the new flat-sided flange nut and show you how to heat sink them into plastic, do a review of the Tamarack Flexure Joint fabrication tools, provide some ShearBan application tips, and talk about ordering Tamarack components. The first new component I will present today is the Tamarack Standard and Adjustable Caps product. These caps are externally mounted cavities to mount and install Tamarack flexure joints rather than vacuum forming cavities into the AFO shell, as is usually done using molding dummies. They are available in all the Tamarack flexure joint sizes and in black or natural color. The caps were developed to accomplish several purposes: to allow for easy conversion of a solid ankle AFO to one that is articulated without having to pull another AFO shell, to make fabrication easier when laminating an AFO shell using composite materials such as carbon fiber laminations and/or leather systems. And the caps secure each Tamarack flexure joint between the injection molded cap and the AFO shell to maximize structural attachment, stability, and function by the flexure joint in all planes. The caps kit includes all the cap parts you will need to fabricate the orthosis. The Tamarack flexure joints are sold separately. Tools as shown here are very basic. Each package contains two each of the Tamarack flexure joint caps number 1 and number 2, the mounting hardware, the drill guide, and ShearBan cosmetic flange nut cover patches. Notice that each of the standard and adjustable Tamarack flexure joint caps has a number on the inner side of the cap. Use a number 1 and a number 2 on each side of the AFO for each flexure joint. This is to make it easy to pair the caps with the joints. The caps also have directional arrows on the outside of each cap. These arrows indicate the anterior direction for usual applications. The caps require 4 anchoring holes on each side of the orthosis. Affix the drill guide stickers to the orthosis in the location where you want the Tamarack flexure joints. The midpoint of the drill guide should be at the desired axis of motion. Mark the hole locations using a spring-loaded center punch. Then, while the drill guides are still adhered to the orthosis shell, mark the trim line rays, shown here by the red arrows, to guide where the orthosis shell can be trimmed to allow the desired joint motion, such as allowing only dorsiflexion or allowing plantar flexion and dorsiflexion. You are now ready to drill the anchoring holes. Drill pilot holes using a 3/32 inch or 2.5 millimeter drill bit to accurately locate the anchoring holes for each cap. Then drill the final anchoring holes using the drill bit size indicated on the drill guide. This will be 3/16 inch or 4.5 millimeter for the pediatric size and 7/32 or 55.5 millimeter for medium and large sizes. Notice that it is important to drill the holes parallel to the AFO shell and cap for each cap, as shown here in the diagram on the right. With the anchoring holes drilled and the trim line rays marked on the orthosis shell, you are now ready to separate the foot section from the cap section of the orthosis. Use a coping saw or fine-tooth saw blade to make this cut. Using the trim line marks as a guide, grind anterior or posterior of the anchoring holes to allow for the desired range of motion. The images on this slide from left to right show the trim lines allowing both plantar flexion and dorsiflexion, only dorsiflexion, and the example furthest to the right shows too much material being removed. Removing too much material results in poor anchoring and will reduce support to the flexor joint and cap assembly. The longer black flange nuts and longer screws should be used to secure the thicker part of each assembly. The brass flange nuts are to be used with the shorter screws. When installed, you want to make sure that no screws protrude into the interior of the orthosis to protect the patient's skin. If this happens, different screw lengths are available to accommodate different thicknesses of materials. Use a removable thread locking compound such as Loctite Thread Locker Blue 242 or equivalent on all anchoring screws. Remember to attach the caps in the proper direction. The arrows on each cap make it easy to assure this. The flange nut heads typically protrude into the interior of the orthosis by about 1/16 of an inch and is not a problem as long as the ShearBan covers are in place and there is sufficient clearance provided in the orthosis shell. Otherwise, recess them by counterboring if using carbon fiber material or by heat sinking if needed to allow sufficient relief space for each malleoli. I will be showing an easy way to heat sink the flange nuts into an orthosis shell in a following section of this presentation. ShearBan flange nut cover patches may now be placed over the flange nuts. Each patch should cover 2 flange nuts. Note that the fabrication and installation process for the adjustable caps is identical to the standard caps version. The technician should usually install the adjustable cap in the standard position unless directed by the clinician to do otherwise. The adjustable cap, which is the cap with 3 holes, can be located on the cap section or on the foot section. The standard location hole is the posterior hole, as is shown here on the left, black AFO. The boosted anchor hole is the anterior hole, shown in the faded out AFO on the right. Using the boost anchoring hole will increase the dorsiflexion assist by 20% on each side. The clinician will have the opportunity to decide to boost one side or both for a total of increase of 40% dorsiflexion assist. The steps to boost the dorsiflexion assist are simple. First, loosen the main mounting screw on the adjustment cap. Remove the end screw of that cap. Rotate the cap to advance dorsiflexion power and reattach the end screw, then retighten the main mounting screw. The next component to introduce you to is called the Tamarack Plantar Flexion Limiter Kit. The stop allows the clinician to easily and precisely adjust plantar flexion motion. Fabrication is simple and is completed as part of the vacuum forming and usual AFO fabrication processes. Pull a thin stockinette directly over the cast. Attach a Tamarack flexure molding dummy as usual. Then position and nail the plantar flexion stop component in place adjacent, posterior to the flexure joint molding dummy on both sides of the mold. The stop locations are on the medial and lateral sides of the AFO, just posterior to the ankle joint in order to improve the fit of the AFO in the shoe and to avoid shoe collar damage that can happen with a plantar flexion stop located in the usual Achilles tendon area. This location is also more cosmetically acceptable. The tamarack plantar flexion stop component can be located further behind the flexure if desired, but should not be located closer. The tamarack plantar flexion stop can be used with any size or style ankle joint, but all durability testing done by Tamarack is completed using genuine Tamarack flexure joint components. Tamarack does not advocate using the stop as an interior stop. The forces developed when preventing dorsiflexion are too great for the AFO shell and joint components. Remember, do not place the stockinette over the top of the flexure molding dummy or the plantar flexion stop components. You are now ready to vacuum form using standard procedures. Once the plastic has sufficiently cooled and the orthosis shell is removed from the mold, remove the flexure joint molding dummy, but leave the motion limiter stop component in place. Separate the foot and calf sections of the AFO as usual through the center line of the flexure joint and motion limiter using a fine-tooth blade saw, preferably using a coping saw. It can be too easy to grind off material at the flexure cavity, so making marks at the center of the joint cavity will create reference points to ensure that you do not grind here. Make these marks on both the foot and calf sections. Grind to expose the adjustment screw heads. Then remove the adjustment screws from the adjustment screw housing, which is not shown on this slide. The screw direction will be reversed when installing the components, but it is positioned in this way for vacuum forming, so grinding does not damage the threads on the end of the screws. Use caution to avoid removing the centerline mark and thus material from the midpoint area of the flexure joint cavity. Grind at the black stops as needed for the desired ankle range of motion between 0 and 15 degrees. The AFO would not be assembled yet as is shown here, but the image shows the black stop and how it was ground. With the adjustment screw removed, use a 5mm drill bit to pass through the adjustment screw housing and drill the access hole on the proximal side of the motion limiter cavity. It might be easiest to drill using the threaded barrel as a guide, drilling from the bottom up. Reinsert the set screw with the head located proximally. Access for adjusting it will be via the hole in the orthosis shell. Finish installing the Tamarack flexure joints and assembling the AFO. When the adjustment screws are in their final position, per patient evaluation, the clinician should use a removable thread locker to hold the screw in place. We use Loctite Thread Locker Blue number 242, but any equivalent will work. We now have flat-sided flange nuts available. They were created for a customer that requested this variation because they wanted to heat sink the flange nuts into the shell. This new version accommodates and enhances their manufacturing process and final product's quality. Heat sinking with the flat sides prevents the flange nut from spinning in the shell. The current spanner tool is not necessary and in fact cannot be used because there are no longer grooves for the pins on the spanner to attach to. This new hardware option is available to anyone. The part number is 740-3LM. They are available in the size for medium and large joints. This information can also be found on the ordering guide, which is available on the Tamarack website. Recessing the flange nuts may be necessary at times when there is not sufficient clearance built into the orthosis for the malleoli. Of course, there needs to be sufficient plastic wall thickness to do this. Recessing also helps to assure that the flange nut does not spin. If the orthosis shell is made using carbon fiber, the best way to recess is to counter drill, since you will not be able to remold the area around the flange nuts. Recessing the flange nuts into the polypropylene by heat sinking, whether they are Regular flange nuts, or they are the new flat-sided variety, is very easy. Each nut takes about 30 seconds. You will likely be faster doing this than I am. If your orthosis is lined with foam padding, recessing may not be needed, but if so, you will need to pull back the padding before applying heat. First, assemble all the parts as usual. This applies to any Tamarack flexure joint product, including the caps. Snug up all the screws, but don't apply thread locker yet. We use the Rober MT-770 micro torch shown here, but any similar torch will work as well. The torch needs to be capable of a narrow, very focused flame, which I set on low, and be able to direct the heat to focus on the flange nut. Work on one flange nut at a time if this is new to you. You may be able to do pairs once you feel comfortable with this. Apply heat for very brief amounts of time, on and off, and allow the flange nut to heat up the plastic. Do not overheat. You will notice the flange nut begin to sink in. It is being pulled down into the plastic by the tension from the previously snugged up screw. As you continue to heat on and off, try tightening up the screw, watching closely to see that the flange nut does not spin. If it begins to spin, stop turning the hex drive and wait a very short time, then try again. It is simply a matter of how hot the nut and plastic are. As you try to tighten the screw, the perfect combination of heat will allow the flange nut to be pulled into the plastic without spinning, and the screw will actually feel loose as you turn the hex driver. You might find it helpful to buff the area to smooth when you are finished heat sinking the nuts. Otherwise, you can cover the flange nuts with the ShearBan cosmetic patches. The image on the right shows you how the comparisons of a flange nut that is recessed and one that is not. Since this presentation is intended for technicians, we thought it would be good to include a review of the fabrication tools that Tamarack has developed to make fabrication of the Tamarack flexure joints easier and optimize their function. We hope you are familiar with these tools already. The first tool here is the hex driver. There are two sizes, a 2 mm for pediatric joints, which use the M3.5 screws, and a 2.5 mm for medium and large flexure joints, which use the M4 size screws. This is a tool that does not need any explanation. The hand punch tool is for punching the attachment holes in the AFO shell. It places them at the perfect location and angle for installing the screws holding the flexures in place. The angle of the hole is as critical as the location, since the usual perpendicular hole alignment does not apply here. So drilling a hole, even if the drill bit did not walk a little, will result in malplaced hole, making the hardware not line up. Forcing the screw is likely to cross threads in the brass flange nut. In a hand punch tool upgrade done several years ago, Tamarack added a guide pin behind the die on the hand punch. This makes punch angle alignment foolproof and the hole very precise. Earlier versions do work well, but the technician must make sure that the hand punch is held so that the jaw head is parallel to the flat inner side of the Tamarack flexure joint. The image on the right shows the correct angle well, and also shows the new guide pin. The punch pins themselves are quite durable but will dull over time. Replacement punch and die parts are available to keep your punches operating properly. Each kit has a new punch, die, and a set of pins. Be sure to order the correct size. This is unique for each size of the flexure joint. The part numbers shown here can also be found on our ordering guide that I mentioned earlier, located on the Tamarack website. The spanner tool is a wrench that fits into the notches of the flange nuts to hold them securely while turning, most often needed when removing the screws. You can use this when installing, but is usually not necessary. The spanner, if mounted in a bench vise rather than holding in your hand, will give you much better performance and control as though you have a third hand. The spanner tool comes in 2 sizes to fit the pediatric size and the large and medium sized tamarack flexure nuts. One application that having the spanner mounted in a vise is especially helpful is when you are installing a dorsiflexion assist joint in backwards to resist plantar flexion, such as you would for a child having mild crouch gait to give a knee extension moment. The dorsi assist joint must be installed under some tension in this application, but is much easier with the spanner wrench in a vise. Next, we wanted to give you some ShearBan application tips. ShearBan, as we hope you are all familiar with, is a great material for strategically reducing friction at contact points, helping to prevent skin injury, which is usually called pressure spots, and to prevent discomfort that often limits function of the patient. ShearBan is now also available in black, so matching different device colors is more achievable. You likely know that there are suitable applications on every type of footwear and orthotic and prosthetic device. Installing ShearBan onto nearly flat surfaces, surfaces with very mild contours, or onto surfaces with one direction contours is very easy. Installing ShearBan on complex, deep contours or around brims takes a little know-how, so I am including some application tips in this presentation. If you have found different approaches, we are always happy to learn from you. Please let us know if you do. Installing ShearBan onto footbeds or insoles is a very effective way to improve patient outcomes. When you are locating the patch over a deep contour, such as the metatarsal relief shown here, first cut the patch to size. The perimeter of the patch should extend slightly beyond the relief area, about 25% larger area than the area of skin trouble. Using the pressure relief contours is a good guide. Doing so will place the perimeter edge of the ShearBan patch outside the hazard zone and will transition the very low friction zone into the neighboring safe zone that has higher normal friction. The very thin edge will cause no harm at all. Apply the patch lightly at the perimeter, then spot heat gently, being careful not to scorch the ShearBan or orthosis material. Then, using a cotton stockinette, press the ShearBan down into the contour in a circular motion. Allow air to escape out the edges as you do this. If you have a stubborn air bubble, pierce the ShearBan with a pin to allow it to escape. When completed, press the patch down firmly onto the device to help set the adhesive. Here is another method for when the contour is too deep to use the method just demonstrated. If you know the patch won't lay smoothly, or as you attempt to press it in using the first method, intentionally creating a tight standing fold will be very effective. Begin by locating the patch. As you lay the patch into place, do so while collecting the excess ShearBan material into what will become a tight standing fold. It can help to also spot heat the ShearBan as you do this. It is good to try to make any seam parallel with the line of progression. Some very complex contours will require multiple standing folds. This is okay. When the ShearBan is placed into the contour, begin creasing and tightening the standing fold into one crisp edge. This will be easy to cut off using very small curved surgical scissors. Once cut, press the patch and seam down into the device. It will be extremely flat. Another option is to cut wedges out of the ShearBan to create darts. Try to get the darted patch installed with as little gapping as you can. I will typically use the method with the standing seam. This produces a perfect dart and is so very easy to do. Another tip for any application is to trim the corners on the patch. This will greatly improve cosmesis of the final product and will also help prevent the patch from loosening at the corners as the device is being donned or being used. A simple crafter's die cutter shown on the bottom right was used to trim the corners on the patch on the image above it. The die cutter is a nice little tool to have at your bench. The final step with any patch application is to press the patch down firmly onto the device to maximize the bond. Inlaying is a method we use when we have the device, the mold, a vacuum table, and a heat source available. Inlaying the ShearBan patch down into the device improves product cosmesis and creates a very nice looking outcome. Most often the device where this is a good match is the Plastizote footbed from a Crow Walker or other similar footwear devices. Doing so is optional, however. We know that the body heat and downward pressure that the patient will put into the device will do this as well over a little time. To inlay the patch, size and locate the patch onto the device. Use the standing fold method if needed. Gently heat the plaster model as that heats up to normal vacuum forming temps for whatever material you are using, begin to also spot heat the patch on the device. Place the device onto the mold and then draw vacuum on it. Allow it to fully cool before removing vacuum. The result is beautiful. If it is not possible to use a vacuum table but you have the mold available, you can do this by hand as well with nearly the same result. These images show close-ups of the inlaid patches. The edges of the ShearBan are embedded nicely into the foam for a very smooth appearance. As mentioned before, it is not necessary to do this because the edges do no harm when they are located outside of the hazard zone, but it is undoubtedly a nice cosmetic solution. Applying ShearBan to a brim or around an edge is very easy. Simply align the patch on the inner or concave side of the device shell. Allow for sufficient material to wrap over the edge by approximately a half an inch. Gently heat the ShearBan and begin wrapping it around the brim edge evenly from one side to the other, left to right. Trim any excess material that may have collected into a standing fold if necessary and trim that off. Press the patch down well in place when you are done. Many patch applications into shoes are very easy, mainly due to the ease of access and minimal contours to fit the patch into. The upper left image shows a typical application at the arch area. A good way to proceed is to apply a patch onto the insole, wrapping some over the edge, and then a patch on the shoe in the arch area. This essentially protects that one area, but allows you to remove the insole when needed. The center image shows a simple solution to protect the posterior calcaneus and Achilles tendon area. The shoe collar shapes and styles vary greatly. This particular collar is the easiest application. I will show you a more complex collar in the next slide. The image furthest to the right shows the application area through the cutout window in the shoe to show the way to protect the dorsal aspect of the toes IPs. This application can be a bit difficult because access in some shoes is limited. I will give you tips for this in a following slide. For the more difficult collar shapes, this series of images demonstrates a solution. Shown here from left image to right, first locate the patch to mark where you can cut away to form tabs, and then cutting off the excess material which forms the tabs. Dry fitting a patch to confirm coverage and shape and location before removing the paper backing is a good general tip for any ShearBan patch application. Once you are happy with that, remove the backing to expose the adhesive side and align the patch into position. Here's another general tip for any patch application. Do not press the patch into the device firmly initially. This allows you to adjust the location easily without damaging the adhesive. When you like the placement, begin to bring the tabs over the top and to the back side of the collar. As with any application, gently heating the ShearBan will soften it and make it more pliable and easier to stretch into place. Heating will also help the adhesive bond onto the surface material, which might be padding, plastic, or fabric. Last, press the patch firmly into place in the shoe. The folded over tabs will help keep the patch from edge peeling if the patient dons the shoe improperly. The last application area is placing a patch into the toe box of the shoe. Open up the shoe as much as possible, but that is often not as much as you would like. After identifying the location of the patch from the outside of the shoe, press from the inside of the shoe with your fingertips as a way to check the dry fit. When placing the patch, hold the patch as shown in the image at the left on this slide. With the paper backing is removed only halfway. The ShearBan good side is down here. This limits the amount of exposed adhesive, allowing you to then place your hand and the patch into the shoe and then into position. It can take a couple tries to get it where you want it, so do not press the patch down firmly yet. When you are happy with the placement location and the patch is lightly tacked into place, peel off the remaining paper backing and begin securing the patch into place, pressing it firmly into the shoe materials. An alternative to using your hand is to use long tweezers. This can be helpful for reaching into a space that your hand simply cannot fit into. Just in case you are not familiar with this popular idea, I wanted to make sure that you knew that there were also rivet cover patches available, which greatly improve neatness and cleanability of any orthotic or prosthetic device. Rivet cover patches are available in beige or black and come in two sizes, 3/4 inch and 15/16 inch circles. In case you are responsible for ordering component inventory, we have developed an ordering guide for a quick reference. I have mentioned this several times throughout this presentation. That guide is available on the Tamarack website, which is www.tamarakhti.com. And did you know that the Tamarack flexor joints are available in bulk? Purchasing in bulk may improve efficiency if your facility has high volumes. They come in 5 packs, 10 packs, and 100 packs. I hope that you have found this presentation helpful for your daily work. You can download product how-to guides and other helpful information right from the Tamarack website. Please look there for these helpful guides. You can also call Tamarack, and when you do, you will always reach a live person if calling during normal office hours, which are Monday through Friday, 8 to 4:30 Central Time. Our phone number is 763-795-0057. We love to help our customers and hear their feedback. Please always feel free to call or email us if you have any questions, problems, or ideas. Thank you for attending this presentation.